Now, it's a really important idea to be able to take those linear concepts we've been learning in this unit and be able to apply them to a problem that's set up with language. Because, of course, we know in statistics what we say is, in many respects, more important than the numbers that we're putting in there. So we have the average time Americans spend watching television has increased approximately linearly from 30.9 hours per week in 2002 to 31.7 hours per week in 2004. That's not a question, so I think it should be a period there. Anyway, let A be the average time in hours per week Americans spend watching television in the year that is T years since 2000. Okay, so there's a lot of information there to unpack. First of all, we're talking about how much time people spend watching TV. So that's good to know kind of what we're talking about. And then it's increased, so it's gone up approximately linearly, meaning it sort of forms a line going up from 30.9 hours per week in 2002. See that part? To 31.7 hours per week in 2004. Right, so it's giving us kind of some pairs here, right? And that's what they first want us to know. They say, write the given information as a set of ordered pairs. Well, calendar year is one of your variables. So you have T, which is calendar year, i.e. the year on the calendar, and you have A, which is the average time hours per week Americans watch TV. Okay? So which one of those is independent, which one is dependent? Well, like most things, calendar year is independent, right? Calendar year is not something we can really affect. So it tends to be independent because it keeps marching on without us. And then the A is the dependent, like your Y. So remember that independent is sort of like X, right? And then dependent means it's sort of like your Y. I'm putting it in quotes because it's not the letters we're going to use. We're going to use T and A, but the X and Y are the way that most students usually initially think about these topics. And it is so smart to do a couple things. One, to kind of underline the important parts in your thing, but two, to kind of set up for yourself which one's coming first, which one's coming second, and how that's going to look in an ordered pair and which each variable is. Even if they don't ask for it, write it down somewhere because it really helps to figure out, hey, what variable was what. And that's going to be true even in the statistics sections in Unit 7. You got to know which one was kind of your X and which one was kind of your Y. Now, they asked us to set up two ordered pairs for the given information. It's an ordered, two ordered pairs, but it's two because there's two pieces of information here. So we've got T comes first, then A comes second. So we've got, time, which is 2002. Oh, except we got to be careful. I lied a little bit. It's years since 2000. It's calendar years, but since 2000, that's a big deal. Better underline that as well. Right? Since 2000, that's going to mean, or I'll bold it, that we're not going to write this as 2002, comma 30.9. Which might be what you'd initially think, but we don't want to do it that way. Even though it is 2002, it comes first, right? Remember, we go X, comma Y, and all that good stuff. So even though that's the case, we don't want to do it this way. We want to do 2. Now, where am I getting 2 from? Well, if you take 2002 and take away your starter year, basically they're telling you the starter year is 2000. In fact, I'll make a note of this. It's over here somewhere. Note. Starter year equals 2000. That's when T is equal to 0. Okay. Starter year, which means here, slash, right, is 2000. Okay. So if T is equal to 0 is 2000, then 2002 is 2 years later. You can just subtract. So it's 2, comma 30.9, and then the other point would be 4, comma 31.7. There we go. We got our 2 points right there. That's what they were asking for. Now, they want us to find a linear equation to describe that data. Well, funny you should ask. Okay, so remember how, let's see, slope is the change in the y variable over the change in the x variable, right? So it's change in y over change, change in x. Now, why am I putting them in quotes? Well, because we use y and x for general times, but we don't have y and x here. We have, well, what's our y variable? You already wrote it down. The y variable was the a right here. So we want the change in a, let me erase, over the change in t, right? Because that's our x variable, or t is our x variable, and a is our y variable. So instead of y2 minus y1, which is what you guys are used to, we're going to do a2 minus a1 over, instead of x2 minus x1, we're going to go t2 minus t1. Or you could use y and x, but you just have to know which one was which, right? Okay, so let's see how that looks. That would be, we need our variables. Oh, if only we had 2 points. There they are. So we have 31.7 as our A2. 31.7, oops, I typed it wrong. 31.7 minus 30.9 over 4 take away 2, which is equal to, let's see, 0.8 over 2, which would be equal to 0.4. So there's our slope right there. Now that's not all we need. We need more than just the slope, but that's a good start. Okay. So we want to find the equation. We've only found the slope part of it. Oopsie. So now we need to find y equals mx plus b, except it's not y and x, right? Our variables we set up in part A are a is the y variable, t is the x variable. So it's a equals mt plus b. Okay, a equals, we found the slope already. We found the slope to be 0.4, so 0.4 t plus b. Now a for us, and b, and t, and all this good stuff. What are we going to do? Which one of these letters is the one we need to find? B, right? We need a number for b. We need it to be like 0.4 t plus 5 or something. So we're going to take one of our points. Either one will do. I'll use the 30.9. So 30.9 equals 0.4 times 2 plus b. Okay, so that's 30.9 equals 0.8 plus b, because 4 times 2 is 8. Oops, let me make this a little bigger so you can see more. Come on. There we go. Now we need to subtract 0.8 from both sides. Right? Get this the heck out of there. Because you want to solve for b. You want to get b by itself. So this is gone. Right? 0.8 minus 0.8 becomes 0. So you're left with, and over here on the left, 30.9 take away 0.8. 9 take away 8 is 1, right? So it's 30.1 equals b. Like that. I want to underline this. There we go. And that means we're all done, because we can say y equals 0.4. Oh gosh, not y. I'm being dumb. A equals, that was our y variable, 0.4 t plus 30.1. There you go. All set. So we found our slope up here first, right? Slope. That's what we found. Then we found b. That's what all this work is to do, right? We substitute and find b, and then we find our equation. All good? All right, now, what was the slope and what does it mean? Hold on, let me fiddle with this for a second. Poof, there, I had to change the order a little bit. Put one on one side, one on the other, just so I could make sense of this. Okay, now what was the slope and what does it mean? So hopefully you all know the slope was 0.4. We found it together. Okay, that's m. I guess I should say that. M equals there. Now, what did it mean? Well, notice it's a positive number, and that shouldn't be any great shock to us because they say right here that it's increasing. See that? Do it that way. It's increasing. So you can see this is positive. That's why it's increasing. So what we can say is, all right, let me put it this way. Okay, remember how first of all, anything we do could be over 1. So I can say, look, the slope was 0.4. We know that's 0.4 over 1. Now, why am I doing that? Well, because remember, this is what we found. Change in A over change in T. That's what we said right up here, right? When we found the slope in the first place, we said, hey, that's change in A over change in T. Okay, so it was 0.8 over 4, or excuse me, 0.8 over 2, which I didn't bother writing it, but that's 0.4 over 1, and then we just kind of simplify that down to 0.4, because remember we like unit ratios, uni meaning the denominator is 1 for rate of change. So we find that the slope was 0.4 over 1. So yeah, when I write it, I write 0.4 because I'm lazy, but it's really 0.4 over 1. And that's change in your y variable over change in your x variable. Yes, write all this down. Don't just write 0.4. I'm getting at something here, which is that ratio, that unit ratio, that rate of change is how we interpret these things. So when they say, what does it mean? It's saying, hey, write this kind of up. Write this ratio that you're talking about up in words. So we say for every year, or for every increase in year, or every time the year goes up by 1. Right? So for every year, let's say that goes by. For every year that goes by, the year, because it was calendar year, that was our variable, right? It was years. See, it helps if you have all this written out. So for every year that goes by, then this A, this y variable is changing. So the average time Americans spend watching TV. So the average time Americans spend watching TV increases by, oh, you know what? Hold on, let me put this down here just so it kind of flows there. All right, so the average time increases by about 0.4 hours per week. Got to put your unit in there. So like, you can't just say 0.4. 0.4 what? So that's why I wrote right here, hours per week. So I'm telling you guys, you do this part A, it just helps you so much later on. It helps you figure out what your variables are here for the slope calculation, and it helps you figure out your interpret part if you write it all down. Figure out which one was your independent, which one's your dependent, and then you kind of can use these words that they wrote right here. Americans spend watching TV in hours per week. See right there? They're giving you your units. So down here you can say hours per week. All right, now what was the A-intercept? That's the letter B right here. So you'd say, okay, that's 0, comma, always 0, comma. It's not 30.1. I know you want it to be, but it's not. It's 0, comma 30.1. Okay. All right, now what does it mean? Well, there's 2 numbers there, and you have to interpret both of them. So 0, comma 31, 0 was T, and T was calendar year, right? Because T was first. So you'd say in the year 0. Just kidding. There is no year 0. Haha. It's the year 2000. Remember, that was your starter year. See, I even wrote it right over here. T equals 0 is 2000. Okay, so in 2000, what? The average amount. There's a lot of ways you can say this. The average amount of TV Americans were watching, or how about this? Americans watched an average of, or watched, how about this? Watched 30.1 hours per week of TV on average. Or watched about 30.1 hours per week, or, right, something like that. You want to make an English sentence that makes sense of this and that is mathematically correct. So you can say things like, they watched in 2000, TV watching was about 31 hours per week on average for Americans, something like that. So Americans watched about 31 hours per week on average. I should say the word about, because we don't know it was exactly this. We just think it was about that. All right, we're all done with that problem. I'll see you back here for the next one.